Hi everyone, welcome to Numeric Learning, and today we will be solving NCERT Exemplar Exercise 3.2 of Chapter 3, which is pair of linear equations in two variables. So we have already solved NCERT Exemplar Exercise 3.1. Okay, so today let's go with 3.2. The first question is, do the following pair of linear equations have no solution? Justify your answer. So you are given three questions. Let's do it one by one. So the first question is 2x plus 4y. But before getting into this, you should know what is the condition for no solution. So what is the condition for no solution? The condition for no solution is when the lines are parallel to each other. Okay, that's when the system is highly inconsistent, and the way you can identify is when the coefficients of x, that is a1 by a2, is equal to b1 by b2, which are the coefficients of y, but these are not equal to c1 and c2. So this is the condition for no solution. Now let's check for the first one. So you are given 2x plus 4y equal to 3, and you're given 12y plus 6x. So let's rearrange it and write. I'll write 6x plus 12y is equal to 6. Okay, so this I can also write it as 2x plus 4y minus 3 equal to 0, which is of the form a1x plus b1y plus c1 equal to 0. And here the second equation I can write it as 6x plus 12y minus 6 equal to 0. Let me take the ratio a1 by a2. So a1 by a2 is nothing but 2 by 6, which is 1 by 3. Okay. What is b1 by b2 here? 4 by 12. This is also equal to 1 by 3. What about c1 and c2? c1 by c2 will be equal to minus 3 by minus 6. Okay, which is equal to 1 by 2. So what you see here is that the ratio, therefore you can write a1 by a2 is equal to b1 by b2, but this is not equal to c1 by c2. Okay, therefore you can write the given system of equation has no solution. Okay, because that's what is the condition, right? a1 by a2 is equal to b1 by b2, but that's not equal to c1 by c2. It exactly satisfies our given set of linear equations. So you can write, therefore the given system of equations has no solution. That's your answer. Okay. Let's move on to the second question. Okay. X equal to 2y. So the second question is x is equal to 2y and y equal to 2x. Okay, so we can write either x minus 2y equal to 0, and I can also write 2x minus y equal to 0. So when I take a1 by a2, the coefficient of x in the first one is 1 by 2. Okay, what is b1 by b2? It is minus 2 by minus 1 or 2 by 1. But looking at these two ratios itself, we can see that a1 by a2 is not equal to b1 by b2. Therefore, this is a condition wherein the system has unique solution. Right? Wherein you have intersecting lines. So this system of equation does not satisfy the question that is given, right? This will not be having no solution. It will be having unique solution. Okay, that's the answer. Okay, you can just write, since a1 by a2 is not equal to b1 by b2, therefore the system has unique solution. Okay, it does not satisfy the condition of having no solution. So let's move on to the third question. 3x plus y minus 3. 3x minus y, what is it? 3x plus y minus 3 equal to 0. And the second equation is 2x plus 2 by 3y equal to 2. Okay. 2x plus 2 by 3y is equal to 2. So what is your a1 by a2? Directly let's write a1 by a2 is nothing but 3 by 2. What is b1 by b2? b1 is nothing but 1 divided by 2 by 3, which is nothing but 3 by 2. Right? And what is c1 by c2? It's equal to, see, c1 here is minus 3. c2 is, if this comes to the left hand side, it will become minus 2. So minus 3 by minus 2. Minus 3 divided by minus 2, which is also equal to 3 by 2. When all the three ratios are equal, since your a1 by a2 is equal to b1 by b2 is equal to c1 by c2, what is the condition when all the, that means it has infinitely many solutions. Okay. Therefore, it has infinitely many solutions. So this third question also does not satisfy the condition of having no solution. So you just have to check for each one, and I think it's only the first one, right? It's only the first question that satisfies the condition of having no solution. Remaining two questions do not satisfy, right? I hope you understood. Let's move on to question number 2. Okay. Do the following equations represent a pair of coincident lines? Justify your answer. So what is the condition for coincident lines? Let us write the condition for coincident or overlapping lines is nothing but all the three ratios are equal. A1 by A2 is equal to B1 by B2, and this is equal to C1 by C2. This is the condition. Now we have to just check if the given equations, they represent a pair of coincident lines. Let's get the first one. So according to the first question, you are given, let's write the question again, 3x plus 1 by 7 y equal to 3, and you're also given 7x plus 3y is equal to 7. Okay, so what is a1 by a2? a1 by a2 is nothing but 3 divided by 7. What is b1 by b2? b1 is 1 by 7 divided by b2 is 3. Okay, so here, whenever you have fractions, you will combine it like this. Numerator of the above fraction with the denominator of the below fraction. So what do you get here? This is nothing but 1 divided by 3 into 7. 3 sevens are 21. Okay. And what is your C1 by C2? Here itself you can see A1 by A2 is not equal to B1 by B2. So we don't have to even check for C1 and C2. So you can write, therefore, since A1 by A2 is not equal to B1 by B2, therefore it is a condition of unique solution, which means the lines would intersect at a point. Okay, so this is the first one. It is not satisfying the condition of coincident lines. Let's move on to the second question. Minus 2x minus 3y equal to 1 and 6x plus 6y plus 4x equal to minus 2. Let's write the second question. So minus 2x minus 3y is equal to 1, and the next equation is 6y plus 4x is equal to minus 2. Let's rearrange it and write. So you have minus 2x minus 2x minus 3y equal to 1 and 4x plus 6y equal to minus 2. What is a1 by a2? Is equal to minus 2 by 4, which is minus 1 by 2. What is b1 by b2? Minus 3 by 6, which is again minus 1 by 2. And what is c1 by c2? It's equal to again minus 1 by 2. So therefore since A1 by A2 is equal to B1 by B2 and this is also equal to C1 by C2, therefore they are coincident lines. This given system of equation represent coincident lines. What do you mean by a system having coincident line? That means they have infinitely many solutions. Infinitely many solutions. Okay. Let's move on to the third question. X by 2 plus y plus 2 by 5 equal to 0 and 4x plus 8y plus 5 by 16 is equal to 0. Okay, so let's write that question. So here x by 2 plus y plus 2 by 5 equal to 0. I hope it's correct. And 4x plus 8y plus 5 by 16 equal to 0. Let us check what is a1 by a2. a1 is 1 by 2 divided by 4, right, which is equal to 1 by 8. What is b1 by b2? It is also 1 by 8 as you can see, right? The coefficient 1 by 8. And what is c1 by c2? Will be equal to 2 by 5 divided by 5 by 16. So this is nothing but 2 by 5 multiplied by 16 by 5. Right? I don't think you can cancel it. So you have 32 by 25. So here you can see, therefore, A1 by A2 is equal to B1 by B2. But this is not equal to C1 by C2. What is this condition? This is the condition of lines being parallel and no solution. So you can write, therefore, these system of equation, the given system of equation represents parallel lines and they have no solution. Okay, so all the three conditions, right? The condition wherein you can identify if a given pair of equations have unique solution, that means the graphically when you represent them, they will intersect each other, and if all the three ratios are equal, then that means they are coincident or overlapping lines, wherein you have infinitely many solutions. And the last third condition is, the third category is when the first two ratios are equal and it's not equal to the third. That means the lines are parallel and they represent no solution, and these are inconsistent systems. Okay, so we have done all the three questions of question number 2. Let's move on to question number 3. Yes. Are the following pair of linear equation consistent? Justify your answer. So let's understand what do you mean by consistent. So consistent system means a system that has at least one solution. Okay, consistent system means a system that has at least one solution. What do you mean by at least one solution? It can have one or many solutions. Okay, one solution, that means either one or many solution. So what is the condition for one solution? It is unique solution, right? Unique solution means the lines are intersecting. And many solutions means the lines are coincident. So both, when you have intersecting lines, that means the system has unique solution or exactly one solution. When the lines are coincident over each other, overlapping, that means they have infinitely many solutions. And both these scenarios, okay, both these scenarios, I'll write an and here. Both these scenarios are called as, in both the situations, right? They are called as consistent system because they either have one solution or they have many solutions. Okay, so let us check whether the given pair of linear equations fall under any one of the category. Okay, but suppose what you're getting, is A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2. That means the system is inconsistent. That means these lines are parallel lines. Okay, these are parallel lines. That means they do not have any solution and the system is highly inconsistent. Okay, so be very, very careful about 1, 2 and these 3 conditions in order to check how you can evaluate or understand about a given pair of linear equation is very, very important. So let's solve the first question. It's minus 3x minus 4y equal to 12 and 4y plus 3x equal to 12. So observe here x and y term is in the first and then y term and the x term. So you have to rearrange this. So let's do it. Let's write the first question. Minus 3x minus 4y minus 3x minus 4y equal to 12. And the second equation is 4y plus 3x. 4y plus 3x is equal to 12. Right? So we'll rearrange the second equation and write it below this. So 3x plus 4y equal to 12. The question says, are the following pair of linear equations consistent? Right? So you can either, if the given system of equation, it falls under this condition, that is intersecting or coincident, which means they are consistent. If they fall under this third condition, then they are inconsistent. So let us check the ratio of A1 by A2. What is A1 by A2? Minus 3 by 3, which is minus 1. Okay. Let's check B1 by B2. It's also minus 4 by 4, which is minus 1. Let's check for C1 by C2. Again, so here you can, when you take it to the LHS side, both will become minus 12. So again, it's minus 12 by minus 12, which is equal to 1. So what do you see here? You see that A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2. Right? So this is the condition for no solution. Therefore, no solution. Okay, this given system of equation will have no solution, which means it is inconsistent. That's the answer. Let's move on to the second question. 3 by 5x minus y equal to 1 by 2 and 1 by 5x minus 3y equal to 1 by 6. So let's do the next question. So the second question is 3 by 5x minus y is equal to 1 by 2 and 1 by 5x minus 3y equal to 1 by 6. Let's do it the same way. Let's take our A1 by A2 ratio. So it's 3 by 5 whole divided by A2 is nothing but 1 by 5. Okay, so here this by 5 will get cancelled. What is left with is just 3 by 1. Okay, what is B1 by B2? Minus 1 by minus 3, which is 1 by 3. Now here itself, when you have A1 by A2 is not equal to B1 by B2, that is the condition for unique solution. So we can directly write, therefore, A1 by A2. So since A1 by A2 is not equal to B1 by B2, therefore, you can say that the given system of equations have unique solution. If they have unique solution that means they are consistent. So this given system of equation is said to be consistent because they have one solution. Right? Let's move on to the third question. 2ax plus by equal to a. 2ax plus by equal to a. And the second equation is 4ax plus 2by minus 2a equal to 0, where a and b are not equal to 0. So let me write it. 4ax plus 2by minus 2a, right? Yeah, minus 2a equal to 0. Where you are given a and b are not equal to 0. So here also let us do it the same way. Let's take a1 by a2 ratio. What is a1 by a2? 2a divided by 4a, right? A will get cancelled. 2 ones are 2, 2 twos are 4. So this is equal to 1 by 2. What is your b1 by b2? B, that is the coefficient of y in the first equation, and second one is 2b. So what is it equal to? B will get cancelled in both numerator and denominator. You will get 1 by 2. So here itself you will see a1 by a2 is equal to b1 by b2. What is c1 by c2? So here you have a plus a. If it goes to the LHS, it is minus a. So minus a by minus 2a. Minus a by minus 2a. What will you have? Minus minus will get cancelled. A and a will get cancelled. So this is equal to 1 by 2. Now what do you see? So since a1 by a2 is equal to b1 by b2 is equal to c1 by c2, which means these are the system which will have infinitely many solutions. And they are coincident. Graphically, these will be coincident lines. Therefore, how is the system? It's said to be a consistent system. So, by just taking the ratio of the three coefficients, right? A1 by A2, B1 by B2, C1 by C2, and by checking the conditions, you can definitely say if a given system of equation or a pair of linear equations, whether they are consistent or not. Okay, justify your answer means you have to justify the way we have justified it, right? Okay, based on the given, you have to first write the ratios, justify as to which condition it falls under, and then write your answer. Okay, so that's all about your third question of exercise 3.2. Let's move on to the next question. Yes, the fourth question. I think there's another question in there. So we have done third. Okay, fourth question. So x plus 3y, we have to do it the same way. X plus 3y equal to 11. The fourth one, x plus 3y equal to 11. And the other system is 2 multiplied by 2x plus 6y equal to 22. So 2 multiplied by 2x plus 6y is equal to 22. Okay. So this I can write it as 2x plus 6y will be equal to 22 by 2, which is equal to 11. So what are the two equations? The first equation is x plus 3y equal to 11. The second equation is 2x plus 6y is equal to 11. Right? What do I say about a1 by a2? It is 1 by 2. What is b1 by b2? 3 by 6. So 1 by 2 again. Right? This is equal to 1 by 2. What is C1 by C2? It is minus 11 by minus 11, which is equal to 1. So what do you see here? So since A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2, therefore, what is this condition? This is a condition of parallel lines. This is a condition for parallel lines. That means they have no solution. And when they have no solution, therefore, you can call the system as inconsistent. Okay, now we have completed this question. So there were 4 questions underneath this, and we have done all these 3 questions, right? So let's now move on to the 4th question. Yeah. For the pair of equations lambda x plus 3y plus 7 equal to 0 and 2x plus 6y minus 14 equal to 0, to have infinitely many solutions, the value of lambda should be 1. Is this statement true? So, to have infinitely many solutions, the condition for infinitely many solutions is that all the three ratios have to be the same. That is, a1 by a2 should be equal to b1 by b2 and this should be equal to c1 by c2. Okay, so for the given equations, let's write what is your a1 by a2, lambda by 2. a1 by a2 is lambda by 2 is equal to what is b1? 3 by 6. So 3 by 6 is should be equal to 7 divided by minus 14. Right? So first let's take the first two, right? And then let's take the first and the third one. Okay, so when you take the first two, what will you get? You cross multiply. So 6 lambda is equal to 3 twos are 6. So lambda is equal to just 1, right? When you take the first and the third ratio, what do you get? Minus, so here I can probably cancel 7 ones are 7, 7 twos are 14. This is minus 1 by 2, right? So what do you get? Here you can get 2 lambda is equal to cross multiply, okay, the first and the third ratio. So 2 lambda is equal to, I'm sorry, minus 2 lambda. There's a minus 2 here, right? So minus 2 lambda is equal to 2 or lambda is equal to minus 1. Okay, so in one of the, when I take the first two ratio, I'm getting lambda equal to 1. First and the third, I'm getting lambda equal to minus 1. So what do I conclude by here? What is given? To have the infinitely many solution, the value of lambda should be 1. Is the statement true? So there is no value because lambda is both 1 and lambda can also be minus 1. There is no value of lambda for which the given system has infinitely many solutions. That's how you have to write. Okay. If in both the scenarios, if you were getting lambda 1, then that's fine. Okay, you will have infinitely many solution because all the three ratios will be equal. But then you're getting two different values. One with one of the pair of equation, with one pair of the ratios, you're getting lambda equal to 1. The other pair lambda equal to minus 1. So the final answer would be, therefore, you can write there is no value. There is no value of lambda for which the given set of equations has infinitely many solutions. Okay. This will be the answer for the fourth question. Let's move on to the fifth one. Yeah. For all real values of C, the pair of equations, you are given a pair of equations, say x minus 2y equal to 8 and 5x minus 10y equal to C have unique solution. So what is the condition for unique solution? It is a1 by a2 should not be equal to b1 by b2. This is the condition. You have to find for all real values of C, the pair of equations have a unique solution. Justify whether it's true or false. Let's take what is a1 by a2. It is 1 by 5. What is b1 by b2? So here you have minus 2 by minus 10. Right? Which is nothing but 1 by 5. Right? So here what you have? A1 by A2 is equal to B1 by B2. Therefore, can it have a can it have unique solution? It cannot have. So is it true or false? So what is given is C is a part of C1 by C2, isn't it? Here, when you take the first two ratios, you are saying that A1 by A2 is equal to B1 by B2. But in order to have unique solution, A1 by A2 should not be equal to B1 by B2. right? So it is actually false. But again, let us take C1 by C2. So suppose that you take C1 by C2, what is it? 8 by C, isn't it? Minus 8 by minus C or 8 by C. Now, here what do you see? You cannot have a unique solution, right? So suppose if C is equal to 40, for example, okay, if the value of C is equal to 40, okay, in that case, what will you have? If C is equal to 48 by 40, which will be 1 by 5. In that case, C1 by C2 will also be 1 by 5. And if A1 by A2 plus equal to B1 by B2 is equal to C1 by C2, all the three ratios are same, then it will have infinitely many solutions. Correct? Yes or no? And if C1 by C2 is not equal to 40, in that case, what will be the condition? You'll get a condition wherein A1 by A2 is equal to B1 by B2, but this is not equal to C1 by C2. And what is this condition? It is a condition for no solution, right? So what is given? For all real values of C, the pair of equations have unique solution. For all real values of C. Is it so? Is it that for all values of C, it has a unique solution? No. Okay, so therefore, you can say, therefore, it cannot have a unique solution because here A1 by A2 is equal to B1 by B2. Okay. For unique solution, A1 by A2 should not be equal to B1 by B2. Therefore, the given statement is false. So much of elaborate way you have to write it. Okay. So that's how you have to answer question number 5. I hope you understood. Let's move on to question number 6. Yeah. The line represented by x equal to 7 is parallel to x-axis. Justify your statement. So if you take your graph, yeah, if you take your graph, this is your x-axis and this is your y-axis. So at x equal to 7, okay, this is 0. X equal to 7 is a line which is represented like this. The line is passing through x equal to 7. Okay, and it will be parallel to your y-axis. Always this is your x equal to 7. This will be parallel to y-axis. Okay, it is always parallel to y-axis. So is the given statement true or false? Therefore, you can write the given that, okay, therefore, the given statement, that is the line x equal to 7 is parallel to x-axis. No, it is perpendicular to x-axis. It's parallel to y-axis. The given statement is false. Okay. So there ends our exercise 3.2 of your NCERT Exemplar. I hope you liked it. I hope you understood it. All of these questions are very, very good questions. So let me know in the comments how your learning has been so far with me. And if you're somebody who is watching, without subscribing, please do consider subscribing. It's a huge thing for me. And happy learning. Thank you so much. There's one more exercise, which is exercise 3.3, which we will see in the next video. Thank you.